Well, this m is not a slope. We're using m just as a variable here. So, we are looking for intersection with the line y equals 8x minus 2 at 2 points, 1 point, and no point. What we are looking for is that delta y is equal to a what exactly? 8x minus 2 minus negative x squared plus 4x plus m. So this is 8x minus 2 plus x squared minus 4x minus m. So x squared plus 4x minus m plus 2. So what we need here for 2 points of intersection is that the discriminant end up being positive. This means that we will have one x value for intersection and another different x value for intersection. If the discriminant is 0, the discriminant being b squared minus 4ac, if the discriminant is 0, then we have 1 point, or rather 2 equal points of intersection. If there's no point, well, the discriminant must be negative. So a gives us b squared minus 4ac greater than 0. So b squared is 4 squared minus 4, a is 1, and c is negative m minus 2. Or we could have put square brackets, negative, round brackets, m plus 2 if we want. So this is bigger than 0. That means, so 16 minus, well, actually plus, because minus 4 times minus m is plus 4m. And then negative 4 times negative 2 is plus 8. And this is greater than 0. So 16 plus 8 is 24. We can actually move this over right away. So 4m is greater than negative 24. M is greater than negative 6. Now, I should point out that all the way down to this step here, the entire thing remains the same for the other options. So B is from above, except for the fact that we change the greater than to an equal or smaller than. From above, m equals negative 6 for tangency. For 2 intersections. Now for C, we have from above m is smaller than negative 6 for no intersections. Okay, so what if we weren't dealing with a parabola? Well, there are other curves, such as circles. This here, this is a circle. How do we know this is a circle? Well, what this actually comes out to is x minus 2 squared plus y plus 3 squared. That fulfills the x squared minus 4x part. And then this leaves us with an extra plus 4. We'll deal with that in a moment. This part this deals with the y squared plus 6y part. And that gives us an extra plus 9 over here. How do we get rid of the plus 4 and plus 9? Minus 13 equals k. So this is what we're actually dealing with. We're dealing with a circle that is centered on 2, -3. All right, so the intersection is with the line y equals 8x minus 2. So first, we want to see where it is tangent. Why? Because if we know where it is tangent, then any bigger of a circle is of course going to end up cutting at 2 points, and any smaller at no points. Yes? So find tangency radius first. First of all, we know that if it's tangent, then it's going to be perpendicular. Okay, that didn't come out as well as I'd like, but it's perpendicular, so what do we know? This radius has m equals -1/8 through 2, -3. 2, -3. Do we remember how to do point slope form? It was y minus y1 equals m times x minus x1. So -1/8 times x minus 2 and y minus -3. So y is equal to -1/8 x plus 1/4. And hey, minus -3 is plus 3. So move over and we get that. Equals -1/8 x plus 1/4 minus 3 is, we can write this as 11/4 if we so wish, which helps with subsequent operations because we don't have to convert between partial fractions and improper fractions anymore. So this is the line we're looking for. Where does this intersect with y equals 8x minus 2? Equals 8x minus 2. So what we have is at 8x minus 2 equals -1/8 x minus 11/4. So this here is then (65/8x) and -2 (11/4). That's, well, (11/4 plus 8/4 technically. That's (3/4). We can cross this out, get a 2. Now what actually happens is 65x equals -6. 65x equals -6. and x equals negative 6 over 65. So this is the point at which intersection occurs. Now, the y value then is something we can find just by applying to either of the formulas. And then we can find the radius of the circle. Y equals 8 times negative 6 over 65 minus 2 equals negative 48 over 65 minus 2. So 2 times 65 is 130, and 130 plus 48 is negative 178 over 65. So the radius we're looking for wait a second, what is the formula for the radius? The formula for the radius is, first of all, okay, we know there's center point. And what else do we know? Well, the radius is going to end up being k plus 13 because we move this over. So the radius is k plus 13, and it's from 2, negative 3 to this point. Well, technically r squared is that, but hey, who's counting? So radius is going to be r squared equals k plus 13. So what we're shaping up for is a number that is a little bit big, or rather big to right. So r squared equals x1 minus x2 squared plus y1 minus y2 squared. So k plus 13 is equal to x1 is, well, let's use 2. 2 minus negative 6 over 65 squared plus negative 3 minus negative 178 over 65 squared. So we're looking at equals, well, 2 is 130 over 65, so 136 over 65 squared plus negative 3 minus that. Well, what is negative 3? 65 times 3, well, 60 times 3 is 180, 5 times 3 is 15, so 195. Negative 195 plus 178, too lazy. So 17 over 65 squared. Well, negative, yeah. But even though it doesn't really matter in this particular case. So what we have here is going to be 136 squared over something, which we aren't going to dine to find out for now. 17 squared, 289 over the same something, which is 4225. 4225. So this is k plus 13. That means the next step is going to be k equals, okay, 136 squared plus 17 squared equals 18785 over 4225 minus 13. So 13 times 4225 is what? Okay, we're going to reduce the actual fraction in terms of simplest terms later, but for now, 4225 times 13 is equal to minus 54925 over 4225. So we're dealing with negative 36140 over 4225, because actually going through and crossing out to rewrite the factors is most likely going to be actually longer. Let's do it this way. Okay, 4225. We can obviously factor out a 5. So what do we get left when we factor out a 5? Oh, actually, no, we don't need this for now. 8, 4, 5. Yeah, okay, it ended in 25. Thus, we can obviously factor out 25. But hey, one step at a time, right? So, 5. And we end up with, well, 8. That's 1. And then we get 34. So that's 6. And then 45. Well, that's 9 here. 169 is 13 by 13. If this actually surprised anybody, given the fact that this thing is 65 squared, well, it shouldn't. So, honestly, we didn't really need to do this because it was 65 squared, but we did it anyway. So let's try it for 36140. This form of vertical factoring may take some practice to people who are used to drawing factor trees, which are, oh god, why, levels of, well, big, I guess, is the politest term I can use. So, this, okay, clearly we can start out with a 2 if we wanted, but no, let's do this instead. So 7 for 35, so 11, that's 2, and 14, that's 2 again, and 8. So obviously now we can do the 2, and we get 36, 14, and 2 again, and we get 18, 07. And where can we go from here? Well, we can see by visual inspection that 3 is not going to cut it, because added together, we don't get a multiple of 3. The digits added together. If the digits added together was a multiple of 3, this would be divisible by 3, but it's not. So 1807, is that divisible by 7? Well, 1800 is obviously not divisible by 7. Now, what about, say, 11? Oops, 1807 divided by 11? Wait a second. Do we actually need to use a calculator for that? Not really. Why? Because, oh, hey, if we're going to divide completely, we're going to end with a 7. So how can we end up getting 173 to divide by 11? Well, we can't. So obviously it's not divisible by 11 either. So 1807, can we divide by 13? Oh hey, we can. Divide by 13, and we get 139. Now 139, we must be able to find a factor under 12 if this thing is to be factored. Why? Because 12 squared is 144. But wait a second, we've already tried all the prime factors under 12. So we must conclude that there are no additional factors. So what can we actually cross out here? Well, we can get 5 and 13, 5 and 13. So what this cancels out to is equal to 36140 divided by 65 negative 556 over 4225 is, well, 65 squared, so 65. Okay, so this is the value of k at which this whole thing is tangent. K equals negative 556 over 65 tangency. As you can probably tell, this question is a great deal more complex than the average question that you will likely encounter, but sometimes teachers will give hard questions on tests, and of course there's exams and contests to think about. So at this point we have tangency, but when we make k bigger, radius grows. Bigger radius. So A is k is greater than negative 556 over 65 for two intersections. B, k is equal to negative 556 over 65 for tangency. And C is k is smaller than negative 556 over 65 for no intersection. There you have it. Now, of course, after we do every problem, we should go back and check if we did anything that might be identified as, say, glaringly incorrect. And in this case, that does not appear to be the case anywhere. So, that's it for this problem, and we'll see each other again then, next section.